Hello everyone, today we would like to speak about quantification possibilities together with Raman microscope equipped with multi-well plate. In order to quantify analytes in liquids, we have prepared some test samples. This would be methanol diluted in vodka, and we will start with 0 concentration clear vodka in well A1. Yes, good. Then concentration 1% of methanol in the well B1, then concentration 5% of methanol in C1, %10 D1, 20% E1, and then finally 40% F1. And by the way, our Raman microscope allows automated measurements of entire multi-well plate. And let's say we want to make a calibration model with multiple points of the same concentration. So we will insert F2 for concentration 40, E2 for concentration 20, and so on. Then 10%. %5. Again 1. And clear vodka. Good. When we would like to routinely measure a lot of liquid samples, here we already attached adapter for multi-well plate. If you want to know more how to change adapter from normal sample measurements in Raman microscopy to the multi-well plate, you can find our previous videos focused on that topic. And you see, you just insert it inside, and you have a special screw here to lock the multi-well so it's not moving. Then we come to our software, and in software we connected the RG microscope. We can see that COM port is connected, all stages are ready, temperature, humidity is fine. And the next step, of course, we turn on the laser. This is a 785 laser RG microscope with RG spectrometer inside. We have the visible image of the multi-well plate. And let's check the current position of the multi-well. I suppose we are right now at A1. And from this plate, in order to start from A1, we press this button to start mapping from that position. And then we go to Raman mapping settings. We can enlarge this screen. And XY mapping we set up. This is the first point position. We prepared two lines, 6 well each. So it would be 6 on 2 counts. And the distance between wells in a 48 multi-well plate would be 12.4 millimeters between each, and this you can see here as a step size. So when distance between wells is set, number of wells we also agreed how much we want to map. We set up the file name, let it be the quantification, methanol in vodka, 48 multi-well plate, and basically we start mapping. But before that, of course, we want to get some acquisition parameters. Each spectrum we will collect, for example, 3 seconds and maybe 3 repetitions for averaging its quantification. And very nice. So starting mapping settings, we press start. Here below there is a status of mapping, and I believe it's already the first mapping point has started the map.
We can check it by opening the Raman mapping viewer to be sure how our mapping is going on.
Yes, here, and this is actually already the first pixel. Nice. And I think that this is actually the spectrum of clear vodka, the first point. And I agree with Andrei that we can, here in mapping viewer, we can show trace lines, and let's enlarge this area so we can better see what's happening. So this is a A1 position. And then we can scroll here in lateral dimension, and this would be A2. And if we can see the difference between A1 and A2, it's a concentration 0 and concentration 1%. And methanol peak is supposed to be here, a bit higher than 1000. So you see it's less, then it's higher, and even higher. So it's growing the concentration of methanol. Since we're waiting for the measurements, I also could notice that we measure in a standard multi-well plate made of polystyrene. However, since it's a confocal system, we just focus inside the liquid, and the presence of polystyrene is almost absent. Of course, when you collect long time at high laser powers, it will be still present. But of course, we keep the same distance between well and the sample, so we can subtract it afterwards, if necessary. However, on this spectra, you even may not notice the presence of polystyrene. So this is clear vodka, 1%, 5%, 10%. This is 20%, and this is actually 40%. I think there is something wrong with this by intensity. But let's see how the second line will behave. This one is very good. The reason could be maybe not enough liquid in that cell, or maybe we a little bit mismatch in the center of the well for some reason. But for the demonstration purpose, we can simply skip one point. We have option in quantification if you don't like
Just
the...
we can use some scaling procedures.
Yes. So, and peak ratio would still help us to use that point. So 0, 1, and we can see here that Peak of methanol is slightly higher. 5 and it's higher. All procedure can be way faster if you play with exposure time and number of repetitions. I'm curious to see about that point. Once again, 0, 1, 5, 10, 20. Oh, very nice, this one. And 40 we still measure. And also you can see, you still see the visible image here. So you can control the centricity for each well. Are you precisely in the center or not? And if not, you can play with off-axis and step size to make it precisely fitting to the particular multi-well plate. Now we completed with the measurement. Since mapping is done, we should turn off the laser. And now all the data are ready for analysis, for quantification, prediction, and then we can measure some unknown spectrum and determine its concentration. Andrei, could you try to continue with this process?
Yes, of course. After our data are measured, we can go directly to analysis, but the essential step before the analysis is preprocessing. So we can do some preprocessing in our Raman mapping viewer. We can crop our map in spatial dimension or in the number range. We can we can smooth spectra and subtract background and do some normalization. At this point we will do only normalization. I choose unit norm L1 normalization, which means that each spectra will be with unit area. So, and then after normalization we can export our data.
Maybe in new folder.
Yes, try new folder. MV, for example. And to do calibration, we should switch to the data analyzer. So data analyzer is here. I select and delete all previous spectra, and I'm loading the new one.
It's all in TSV saved.
Yes, actually we can do the same preprocessing with single spectra in the data analyzer, smoothing, background correction, normalization. As we have already done normalization, we will skip this step, and we are going directly to the calibration unit.
Do you think it's enough to get some, in demonstration purposes, meaningful calibration?
Yes.
Okay. And here we can see all the data, and I can see here we can assign some values for every spectrum.
Yes.
So let me quickly do that. The first one is 5% and 10, 1. I look at the positions which attach to multi-well number, like A1, A2, and so on. 20, 0, this last one is 40, and then the second line, like A2, B2, and so on. Again, 5, 10, 1, 20, 0, and 14.
Yes, and before calibration we should split our data into training set and validation set. We can do it manually by clicking in this combo box and choose whether we want to add this data to calibration set or prediction set, or we can just keep it, or we can do it randomly, dividing our set. This means that 70% will be go to the calibration set, the rest to validation set.
Yeah.
Yes, and we choose center data, PLS1 model.
Remind me, center data is
All data, all spectra will be subtracted by mean spectrum of whole data set.
And number of principal components
Yes.
should be as much as possible.
As much, because the model will say us the optimal number we can use in our calibration
But
model.
I assume it's not, of course, enough number of data points for proper calibration.
Yes, it's just for showing the general principles of.
Of using this calibration.
Yeah.
Then we press calibration.
Yes.
And now we can see the calibration data.
Yes, it's true values. It's predicted.
Yeah.
This we have figures of merit, and we can switch between different plots. It's press values, explained variance, explained various our values calibrated, root mean square error, and we can switch, of course, between a number of principal components taken into our model. And we see that adding the 10 model with 10 components is not the best. So leave the optimal one.
It's two. Suggested.
Yes. And we can go back to the data, press for prediction, and can see how our model predict data.
So I see limit of detection is around 1.5%,
Yes.
and quantification 4% for particular data set.
Yes, it is not enough data to do a very precise calibration. So, but for this small data set is good enough to see.
And maybe out of curiosity, let's say we can measure again some sample and try to quantify.
Yes, but before doing this, we should save our model.
Okay. So some name, yes. Maybe
Yes.
here directly.
Just methanol detection or something like that.
Methanol quantification. And
yes, so we can close.
And I turn on the laser. And I do not remember what concentration is this. Maybe actually the highest 40 or.
We can check with our calibration model.
Yeah, so please collect capture. Yes.
Yes. We will capture data, but before doing this, I checked capture and add to data analyzer. So this spectra will be added to the data analyzer. So I press capture.
And we collect 3 times.
3 times by 3 seconds. Yes. Data. Just data.
Okay.
Yes. Switch to data analyzer. It's our data. I skip.
We select this.
Yes. Do normalization.
L1.
L1, sorry. And I press quantify current.
Spectrum.
Yes. We cannot do it because
You should select model.
yes, you are correct. So we
Load
the model. It is green, our model is loaded, and we can quantify it.
39%. So basically 0.3. So I assume it was 40. The sample.
Yes. So actually,
That's how it works. And if I want to quantify more than one sample, like, you know, I measure a lot of samples, the rest of the multi-well points, and I want to quantify all of them together and save.
Yes, so you can check
Let's say
several spectra, go
Mhm.
to quantify selected.
Select it, and it's actually concentration for all of them.
Yes.
One of them is 10%, then 39.8, some 0,
Some zero, yeah.
minus 0 a little
Well.
bit, but it's within the error of the model.
Yes,
And how
yes.
to save all of this?
Just press save, and
And it will be like a table
yes.
in TSV file.
Yes, the name of sample and its predicted value.
Okay, very nice. Great. I turn off the, yeah, I close it. Now we can turn off the laser, we can turn off the visible illumination here. Finally, we can remove back the multi-well plate, unscrew it, unlock. We remove the plate, we can load new data set and continue. This is how you can do automated liquid sample measurements, calibration and quantification, and basically you can decide any multi-well format you want, 48 cell, maybe 96 or so on. Thank you for your attention. I hope it was a useful video to understand how to do quantification with our Raman microscope. It could be applied, I believe, in many areas where you do the analytical chemistry of liquids and you do quantification by Raman spectroscopy. Thank you for your attention.